Okay, so let's just start with graphing the tangent from memory. The parent function points on this thing, there's going to be 3 parent function points that we use in 2 asymptotes, 2 defining features. So total of 5 things that we need for the tangent function. Does anybody remember where the first asymptote over here is located? Negative pi over 2, good, okay. So if that's where the first asymptote is, what was the period of the tangent function? It was pi. So if I add pi to that, it's going to give me over here pi over 2. Okay, so that is the first thing that I would always do to graph the tangent function. So now the y-axis breaks up that interval in half, right? Okay, let's go ahead and break it up into force. So if I go there, that'd be negative pi over 4. And then I split there, that'd be positive pi over 4. Okay, that's all you need to do right now for your x-axis to graph the parent function. Okay, if we were graphing a transformation of it or something like that, maybe we have to do a little bit more, but parent function, that's all we need. When we go across the unit circle, we start dividing sine divided by cosine at 0 degrees, we should have a quotient of 0, or 0 radians, a quotient of 0. Okay. What values, oh, that was too far down. At pi over 4, what is the relationship between the sine and the cosine at pi over 4? Yeah, they're the same thing, so their quotient is 1. And that's an easy point to plot, correct? Same thing happens at negative pi over 4, but their quotient should be negative 1 because the y value at negative pi over 4, oh, not that one, is that one, negative radical 2 over 2. Now, the tangent function is a smooth curve that has to follow these asymptotes. So when we graph it, that's terrible. So let's try that again. So it should look something like that. Okay. Now yesterday I mentioned this, we didn't write it down. I think we should write it down. If we go back to the tangent function, in any calculator, well, TI might be a little bit different, but I type in tangent of x, it's not going to put in my asymptotes. TI is a little bit different. TI really doesn't put in the asymptotes, but it has a structure. If you go into your mode, it's called connected in dot mode for your graphing. And if it's in connected, basically what it does is it finds like the last point that it plotted on a section of the graph and the first point that it plotted on another section of the graph, and it will try to connect them. And what it does is it looks like it puts in asymptotes for us. So if and I don't know if this calculator will do it because this is the newer version of the TI. If I type in tangent of x and graph, anybody remember why it's doing that? Because my window's messed up. So I can fix that by either changing, because right now basically my calculator is in degrees. I can either change my window so it goes between negative 90, positive 90, or I can just change my mode to radian, which is easier. But you see down here where it says right here, it says thick, thin, dot thin. A lot of yours, the older versions will just say dot or connected. And it has to do with what is going on when it graphs these. Okay, so this isn't putting the asymptotes in like I thought it would. So the newer version has fixed this issue. The older versions, what it would do is it would see that it plotted a point all the way up here. Okay, and then when it moved over a little bit on the x-axis, it plotted a point all the way down here. And if it was in connected mode, it tried to connect those 2 points. And it looked like the asymptote that we were interested in. Does it make sense? It's really not. It's very close to it, but it's not. And I don't know if I can... What's that? Why did they get rid of it? I don't, because it's actually a false representation of what's being graphed. If you have a calculator like that, I wish I still had the ROM of the old version. Maybe I do. Maybe I can find it real quick. Do we still have access to the K drive? Math calculator. There we go. All right, so you got this old version, so tangent of x. Now if I go to mode, go down to degree, radian degree, check that. See how it says connected or dot right here? So if I graph it, see how it tries to, it's kind of screwy looking, right? And I don't know if I can get the, there we go. But the idea is that this right here is not, thank you, is not the asymptote. It's trying to connect a point up here and a point up here. It's very, very good approximation, the asymptote, but it's kind of a fallacy. You can change that if that's happening to you on your, you can go to dot and graph, and it doesn't try to connect things then. Okay, so it just plots points. The newer version, let's see this one here. So your silver edition is a little bit better. I'm going to graph it. So they must have fixed it in this. I want to check the mode here. They might have fixed it in this one. Yeah, they fixed the connect thing in this. So this is the newer ROM operating system. And if you have one of these, there are different operating systems that if you want to update it, you go to TI, you plug I think you have to download a program from TI, plug your calculator into your computer, and you can download the new operating system. But what I'm trying to get at is we want those asymptotes, okay? So when I go into this, I want that asymptote at pi over 2. And I want the one at 3 pi over 2. I want the one at 5 pi over 2. But I don't want to write them all out, okay? Because how many asymptotes do we have for this function? We have, what's a better word? We have an infinite number, because this thing goes on forever. So I can't write down all of the asymptotes. But I can say that the first asymptote starts at pi over 2, right? What's the period for the tangent function? Plus pi. So if I add pi, I can get that one, right? But if I add pi again, I get that one. And I add pi again, I can get that one, right? So I'm adding multiples of pi. So I'm just going to say let pi, or take pi, multiply it by k, and then it's going to ask me to create a slider for k. What should I let k be so that it gets in those asymptote positions correctly? Because right now k can be anything, but right there it's 1. That's our correct asymptote, right? At 2, it's a correct asymptote, right? Okay, so I heard whole number, but then if I want that asymptote, it's got to be negative, and that's not a whole number, right? So then I heard somebody say integer, right? So that's what we want. If I make my slider go by 1s, that will make this be integer. And now we can see all those asymptotes in the correct positions. So we want to write, so we'll say the asymptotes are found. Asymptotes are found at x equals pi over 2 plus pi k, where k is an element of our integers. Okay? So that means k could be 0, 1, 2, 3, 4, 5, 6, or -1, -2, -3, -4, all the way to positive and negative infinity. Okay? What is interesting here, I think, is that you don't really have to start with pi over 2. You can start at 3 pi over 2. Okay, and then when I have k to be -1, that would give me the pi over 2 asymptote. And then when k is negative 2, that would give me the negative pi over 2. Does that kind of make sense? So as long as that first pi over 2 that we have in our formula is an accurate asymptote, we add the period times k to it, where k is an integer, we will get the other positions for our asymptotes. Okay? So we have questions on the tangent function. What function is a cofunction of the tangent? Cotangent. What's cofunction refer to? Not reciprocal. So, but the tangent and the cotangent have, that's the one set of trig functions that are actually reciprocals and cofunctions. So sine and cosine are cofunctions, but they are not reciprocals, right? Secant and cosecant are cofunctions, but not reciprocals. Cotangent, tangent are cofunctions and reciprocals. You may remember what cofunctions were. If I say sine and cosine are cofunctions, that means the sine of 60, so the sine of 60, which is that number right there, right, is the cosine of what angle? Cosine of 30. What do you notice about those two numbers? They're complementary. Okay, so the cofunction idea is that they're complementary. So we can use that relationship to help us find the cotangent based off of what the tangent is. Okay, which I think I want to actually investigate that relationship at the end. Let's go through and develop the cotangent using the quotient like we did with the tangent. Because I think that would be the easiest thing for you to do if you get stuck on a quiz that I ask you to graph the cotangent and graph the tangent. The easiest thing for you, I think, would be to grab your unit circle and say, well, the cotangent is the cosine values divided by the sine values of a particular t value, right? Okay. And that's how we've developed the sine, the cosine, the tangent so far, so might as well stay consistent doing the cotangent. Now, the one thing that is a little bit different here, and this is why I wouldn't use the reciprocals, okay, because tangent and cotangent are reciprocal of one another, right? Okay. What was the quotient that provided me this asymptote right here for the tangent? Asymptotes are always division by what? 0. So at pi over 2, the tangent would have been 1 divided by 0. But if I use the reciprocal to graph the cotangent, what's the reciprocal of this? 0 divided by 1. And that equals 0, right? So at pi over 2 on the cotangent, you're not going to have an asymptote. Does that make sense? Right here on the tangent, that was developed by 0 over 1. Okay? But what's the reciprocal of that? That's 1 over 0, right? What does that tell you on the cotangent that the y-axis is in? That is going to be an asymptote. Okay, that's undefined there. So I think using the reciprocal of this graph is hard because of that feature. So I think the easiest thing is to come down here and just grab things off of our unit circle. Now, because of that feature, though, instead of going from negative pi over 2 to positive pi over 2 like we do with the tangent function, we're actually going to start at 0, and we'll go up to pi. So at 0, what is the cosine divided by the sine? What's that number divided? So it's 1 divided by 0. Undefined. At pi over 6, we have radical 3 over 2 divided by 1/2. It's going to be radical 3, right? Pi over 4, 1. That's going to be a really nice point for us. Okay. Pi over 3, be 1 over radical 3. Okay. Pi over 2, 0. That's going to be a really nice point for us, isn't it? Any y value that incorporates a radical is going to stink to graph. So, but if I keep going, 2 pi over 3. Now, what happens here is that this first quadrant, as we go through those quotients, is that going to end up being then the same y values as this quadrant as we go that way? but negative now. So this was that's kind of the transition. So what we're going to say is when I do 2 pi over 3, it's going to be the same as what pi over 3 was, but negative. And then we go to 3 pi over 4. It's going to be the same thing as pi over 4 was, but negative. Another real nice point for us to plot. At 5 pi over 6, should be negative root 3. And at pi, what are we going to have at pi? It's going to be 1 divided by, it's going to be negative 1 divided by 0 again, right? And that is undefined. So we're going to have an asymptote there. Okay? So just like we did yesterday, and I think, I just like to do it this way. You guys are obviously doing it by hand. Just to get you a good visual of the points and make sure things are plotted correctly, I'm just going to type this stuff into GeoGebra. So if we go, so we have undefined at x equals 0. We have pi over 6, comma, root 3. Pi over 4, comma 1. Pi over 3, 1 over root 3. Pi over 2, 0. 2 pi over 3, negative 1 over root 3. 3 pi over 4, negative 1. And my hope is that you can start to see, if we were to compare to what we did yesterday with the tangent function, these points kind of align themselves in a similar fashion that the tangent function points did. Now they're moved over a little bit and they're going in the opposite direction, but it's still the same quotient that arrived on the tangent. They're just paired now with different angle measurements. If we look at those, and now I ask it to graph between 0 and pi, if 0 is less than x is less than pi, let's look at the cotangent. We can see that those points plotted correctly, connected with a smooth curve, would give me the information we need for the cotangent. Now, obviously when we start the cotangent, those are the asymptotes that we're going to be interested in. We're going to graph those first. Okay? Halfway in between the asymptotes, what happens? A real nice point there, right? X-intercept. Really easy to plot. So we'll plot that as a parent function point. Now, halfway in between this interval, where's your y value? At 1. Is that a real easy point to plot? And then halfway in between this interval, we're at negative 1. So my hope is that we use those 3 parent function points along with the asymptotes to help us graph the cotangent. The next asymptote to the right of pi is going to be where? 2 pi. The period of the cotangent is the same as the period of the tangent. They're both pi. So if I graph the whole cotangent function, there's the cotangent function. Okay? And you can see, so now if I wanted the equation for my asymptotes, they're simply at pi k. Okay? X equals pi k, where k is an integer. Okay? Let's put the tangent on top of this. Those two curves, those sets of curves look very similar. Okay? They look very similar, so let's do this real quick. I'm going to show the algebra here. Let's graph the tangent function. Okay? If I take the tangent function and multiply it by a negative out front here, what is that going to do when I multiply it by a negative right there? Flip it across the x-axis, right? Does that, correct? Okay. Now, we still have an asymptote here at negative pi over 2. But let's make that asymptote shift to the right, because that's where the asymptote for the cotangent goes, right? Asymptote for the cotangent is right here on the y-axis. So how big of a shift would I have to push that asymptote here to become that one there? Pi over 2. So if I want to move the tangent pi over 2 units to the right, what do I need to do right here to the x? Minus pi over 2. Gives me that, right? So now if I graph cotangent of x, are they the same thing? Okay. Now, here's what happens a lot. Okay, those two things are the same. And you might see a textbook that says, yes, that is how we can define the cotangent in terms of the tangent. Okay? However, most textbooks don't. Most textbooks, if you guys remember the even-odd properties, if I have tangent of negative t, we can rewrite that as negative tangent positive t. Does that make sense? Right now, this right here is that version right there. Does that make sense? I'm going to take that negative and put it back in. I'll take this negative here and put it back in the argument so that it turns into this side. Is it okay with everybody? So if I go tangent of negative x minus pi over 2, and just to prove that that's okay, if I type in tangent of negative x minus pi over 2, still the same thing, right? If we distribute that, we'll end up with pi over 2 minus x, which is still the same thing. We'll pick up with that tomorrow, or actually Monday. Quiz tomorrow. Have a great day.